Welcome back. We have been building a playlist on YouTube, and the first four, I believe, were uh, just basic steps, and we used a guess the number game, I think. And we tried our hand at tic-tac-toe. We thought it would be harder, it ended up not being hard at all. So then we decided to switch gears and explore machine learning, and we delved into what is a perceptron and tried to learn about it and so forth and so on. Fine, and a few videos of that. Now, then right here, we failed miserably in part 6. We tried to get our very, very basic neural network homegrown, missing a hidden layer, and you should know that if you went through all the videos, to recognize digits, and it failed miserably. We thought there was some errors in the logic, and I believe there were. And so then we decided to punt and back up and try it with just four selections. So draw a vertical line, draw a horizontal line, draw a increasing line, draw a decreasing line, and all that works. So now we're going to take what we learned here with the correct code and retry to see if we can be successful in getting it to train on 10 digits. We are going to do exactly what we did in the previous video. I'm going to feed the HTML and the JavaScript from the previous video, which is the 4 lines that we did. I'm going to feed these to ChatGPT, and then we're going to ask him to talk about, we're going to talk about converting all this to 10 digits. So I have pasted both files, and they're above this area. This all works perfectly. In order to convert this from 4 outputs, line shapes, into 10 outputs, numbers 0 through 9, very, very briefly, is it a lot of change? I understand the HTML is simple. I'm asking about the logic, so let's see what chat has to say. Short answer, no, not a big change. The core logic already supports it. What actually changes? Okay, that's good. So we went from 4 to 10. The UI, yeah, we know. Training labels. Okay, no change needed. What doesn't change? Okay, what does matter? The digits are harder. Sure they are. I know your model is still a single. Yeah, that's fine. Will it work? Well, we'll find out. Okay, yeah. Or switch to softmax plus normalization. So, let's see. Let's see what happens. All right, so you know the routine, hours, chat GPTs. Let's see what happens. And there's the 10 digits. Gone will be the line pattern, right? And instead it will be hopefully 10 digits, 0 through 9. Yep, that's it. Okay, here's the JavaScript file, and yep, he went from 4 to 10. That's it. That was the only change. Very nice. Okay, the moment of truth. So this is where we were back a few videos ago when we crashed and burned and nothing works. Let's see what happens here. Okay, it started up. I'm going to have to scrunch it down a little bit because, wow, it doesn't fit on the page. Too bad, too bad. Okay. Now that fits. I hope we can see the digits. Yes, we can. All right, here we go. First of all, is there an undo? Yes, there is. All right, here we go. 0. Okay, those are okay. The shading is good. The numbers are random. Very nice. I'm going to say yes, it's a 0. I'm going to go 1. Okay. It went biased to 0, so let's see. Let's go with 9. Now remember, this is not trained. Interesting. 9. Let's do 5. We're just going to hop around here. Okay, this is definitely working better than last time. Last time it was not working at all. 7. Yeah. 8. Okay, so I'm going to do this a little bit and I will be back. All right, let's see how we're doing here. Here's a 0. I can't draw worth a. That was not good. Oh gosh. Terrible, terrible. Let me try one more time. All right, here we go. Good. One. Good. Two. Nope. Two. Yep. Three. Nope. Three. A little bit. Three. Yep. Four. Eh. Four. Eh. Four. Yes. Five. No. Five. Yeah. Six. No. Oh, that was terrible. I cannot. I'm getting my hands tired. Slow it down, Eli. Ay, ay, ay. Okay, still got it. Seven. Oh man, my hand's tired. Well, and no. Seven. Yes. Eight. No. Eight. Ay, ay, ay. Yes. Nine. No. Nine. Yes. Now you're thinking, no, it kind of just following you because you keep repeating the same digit. All right, we'll do a random one. Here's a five. Let's see. Five. Wow. Okay, undo. Let's do one. It did it. How about three? No. Seven. Yes. Uh, two. No. Nine. No. So it's Let's review this again. If hopefully if you were following along with the previous videos as we developed our understanding of a perceptron, it has input values. Those in this case for digits, 784 bits of information. That's the equivalent of me drawing a digit. That is one input sample. Okay, remember that. That's one input sample. If I draw another digit, that's another input sample. In here, we have weights and internal model state. Okay, that's different from the input samples. Now, I want to show you something. Okay, let's open up DevTools. All right. Okay. And let's clear that. Let's blow this up. And let's recall. So we're getting okay. This right here is the equivalent of it storing the internal model state. That means that I can recall the browser and it's just as trained as it always was. But this is not input samples. This is the internal model state. So I had an idea, and we're going to feed this to chat. So let me read this. All right. If we grew a list, an array of every drawn digit's data that was fed, aka each input sample. So we're now talking about the input samples, each digit that is drawn. Create a growing list of each digit's data, right? So that when the user clicks the correct label, it trains over the entire growing list. Would that help? Would it help it train better and quicker, even though the model is extremely simple? All right. So let's see what Chad has to say about that. Yes, this would generally help. It's a well known trick. What you're describing is essentially mini batch replay training. What changes conceptually? Right now, you do one sample, immediate weight update, discard sample. You're proposing store samples when the user labels correctly, train on all accumulated sample. So the training becomes online learning, batch replay learning. Why it can help your setup, giving your models extremely simple, stability improves, simple single sample updates are noisy, one bad drawing can swing. Yeah, that's true. Accumulated trading averages out the noise, reduces random drift. So, okay, all right. So let's slower per up. Yeah, that's whatever. Who cares? Okay, so memory growth. Yes, I get that. All right. So let's see. I know we don't have to go with the rest of it. We forgot a very key piece here, and that has to do with undo, because our undo is only a visual undo. And so my point here is that I want us to be able to draw a digit, and if it's bad, we want to hit undo, and we don't want that digit to have made it onto the sample tracking list. You're with me? So let's see. All right, so if we take the current code and we add sample accumulation feature, in other words, the list, can we not add the latest digit on canvas to the list of inputs until the user has hit guess? Or in other words, if I didn't specify that and I just told you to add sample tracking to the code as it stands now, would the digit on canvas have been added to the list by just the mere drawing of it? Because I'm asking a couple of questions with this, like how different is the logic? So let's see what Chad has to say. No, with the code as it stands, nothing gets added to any list automatically just by drawing. Your current system, oh boy, when you call the only time the drawing get input vector. So if you add sample tracking naively, if you simply add something like samples push and place it, then the samples only when train is called, not when drawing, not automatically. Okay, good. Your specific condition only after guess, then you must explicitly do it and later answer. Would the digit on canvas have been added to the list by the mere drawing of it? No. Okay, so this is forcing us to actually think about the code more. Think about this. I draw a digit. I do two actions after that. I hit guess and then I hit a label. Guess is where, oh man, I just screwed up. Anyway, guess is where it tries to guess. I hit the label, that is the confirmation. There are two different if we start adding the feature where it accumulates samples, right, to retrain over the whole list, there's two places we can add the latest sample. We can add it when I hit guess, or we can add it when I hit the label. And you might think, well, it doesn't matter, right? Because once we hit guess, we're committed, right? Kind of. I can hit guess and I can just kill the browser and never have hit the label. And so it did not train. So we're going to have it added only when I hit the label. So during train. Okay, so again, we're going to feed it the JavaScript file and we're going to specify what we want it to do to that file. So here's what I'm specifying. I want the full file back exactly as is, only add the input sample accumulation list, that's the new feature, and only after the user clicks on the correct label is the latest drawn sample added to the list. So here we go. And let's see, and there it is, it's generating it. So, okay, our version, chat's version, let's see what we get. Sample storage. Okay. Now, even though it says storage, do not confuse this with local storage. Okay. This is not local storage. For like, see right here, the model that we saw in local storage, that's this one. This is just in memory. So I would have said comment sample in memory, but whatever. So we have the accumulated sample, and then we have the one we just drew, and that's just the variable for it that saves it. Okay, so what else have we got? Pending sample is, oh, I see. Okay, so during when we hit guess, he moves he moves what we've drawn. Okay, so we're getting into a little bit into the code. So this gets what we've drawn, and it stores it in here, and then this is the addition. Put it inside pending sample. Okay, good, good. We don't add it to the list. We only add it to the list during train, and this happens when we click the label. See, there's the label. Whoops. There's the label. So we've clicked the label. It's time to train, and if we have a pending sample, add it to the list, and then it trains. So, okay. Okay, I'm hoping this is the moment of truth here. We're going to start it, bring it over. Can we see the whole thing? Yes, we can. All right, here we go. 0. Now, the model has stored its previous training. Okay, so it's brought that in. It's not it should not be an untrained model. See, it's not. Okay. It has, as I click that 0, it has just saved its first sample. 1. Now it has 2 samples, and it has trained over those 2 samples. Now we hit a 2. It has trained over 3 samples. Before it was just training on the sample that I just happened to draw. Okay, 3. Let's do a few more 3s. A few more 3s. Okay, a few more 3s. Oh, yeah. All right. 4. 4. Oh, man, I don't know what happened there. That was weird. That was a bug. Oh, I don't know what happened there. I'm not even going to guess. 5. 5. But I don't know that is it doing better though than before we added this feature? Is it? I don't know. I just cannot draw, man. My hand is tired. Okay, that's good. 8. 8. So I'll be back a little bit. Okay. It is inconclusive if our idea worked. And I have another idea, but I don't want to continue with this video. So remember, we are storing permanently in the browser. So that means that when I kill the browser, bring it back a day to tomorrow, a month from now, whatever, it's in the model state. The weights have been stored in local storage, not the samples. What we've done is before our latest change, it would just train. When I hit the label, it would just train on the latest sample. We've added so it accumulates input samples, but only while I'm running it. The minute I kill that browser, that input sample list is gone. So one thing we could do is have a continuously growing input sample list that also gets saved into the browser, permanent storage. However, that does increase memory. And I don't know if it buys us anything, because is our issue the fact that we do not, because our model, our network only has the input and the output. It's missing this right here. Okay, we've gone on way too long, so I'm going to leave the video here, and I will see you next time.